Alright, so today we're going to talk about chapter 4, section 4.1. So use separating variables method to solve ODE, ordinary differential equation. So firstly, let's do a revision. So you have learned a differential equation in Form 5. So this is a very simple differential equation. So when you see dy by dx, if I want you to find the primitive function, so we'll use integration, right? So we will integrate small fx, for example. So we will integrate small fx with respect to x, right? So actually, how can we get this? Actually, we can do the operation like this. It is because dy by dx equals fx exists. This is exist. It means that the primitive function is a differentiable. It means that it is a differentiable function. So if it is a differentiable function, and then dy by dx can be regarded as a fraction. So for dy by dx equals fx, and we can write in this way. So we multiply dx on both sides, we can get dy equals fx times dx. And then we do integration on both sides. Alright, so we do integration on both sides. So we integrate the left hand side, and we integrate 1 with respect to unknown y, and equals the right hand side will be we integrate small fx with respect to unknown x. Alright, so the left hand side becomes y plus constant c1, and equals the right hand side can be the primitive function. Suppose it is capital Fx and then plus constant c2, and however constant c1 and constant c2 can be combined together. So finally it will be y equals capital Fx and then plus 1 constant c. So here actually you may not write out this step. You may just write this step directly, keep the answer in only one constant term only. Okay, so you can ignore this step. Okay, ignore this step. Alright, so let's look at the example. So for example, so dy by dx equals 2x plus 3. So we can multiply dx on both sides. So we will have 2x plus 3. Don't forget the bracket. So times dx. And then we do integration on both sides. So the left hand side is we integrate 1 with respect to unknown y. And the right hand side is we integrate 2x plus 3. And don't forget the bracket. And then dx. So left hand side is y, and the right hand side will be x squared plus 3x and then plus constant c. Okay, so this is the way to find the primitive function. Okay, so actually it is the same as we learned before in Form 5, but here we write one more step. So we multiply dx on both sides. We write the equation in this way. Alright, so now we are going to talk about a new kind of differential equation. So this is a differential equation, and look at the left hand side. Left hand side is dy by dx, and right hand side is a product of two functions with different unknowns. Pay attention, it is a product of two functions with different unknowns. So for this kind of differential equations, we can use a method called separate variables. Separate variables to solve the differential equations. So how to separate the variables? So of course it is very obvious. So we will separate unknown x and unknown y on both sides. So the way is like this. So we will divide gy to the left hand side, so which will be 1 over gy equals dy, and we multiply dx to the right hand side, and sorry, I make a mistake, 1 over gy times dy equals f of x times dx. Okay, so we separate the unknowns. We separate the unknowns y and unknown x, and y is on one side and x is on another side. So now we can do integration on both sides at the same time. And suppose the primitive function of 1 over gy, suppose, okay, so it is capital G of y, okay, and the right hand side, suppose the primitive function is capital f of x, and then plus constant c. So we can get the equation, the solution of the differential equation. Okay, so this is this method is called separating variables. So the idea is when you see a differential equation like this pattern, and you can separate the unknowns. Okay, you can separate the unknowns on both sides. So one side is in terms of unknown y, another side is in terms of unknown x. But however, so sometimes it may not be in unknown y or unknown x, maybe at unknown x or unknown t. So you can also use the same method. Okay, so now let's look at example 1. Example 1. So dy by dx equals 2. So we can use separating variables method. So we multiply dx on both sides, so we can get dy equals 2 dx. Okay, so we integrate on both sides, do integration, and then the left hand side will be y, the right hand side is 2x, and then plus constant c. Please remember to add constant c here. Okay, so this is example 1. So example 2. So let's check whether we can separate the unknowns on both sides. So of course it is very obvious that we can use separating variables method. Okay, so by using separating variables method, we can get y times dy equals negative x dx, and we do integration on both sides, and it will be and now we find the primitive function respectively. So the left hand side is 1 over 2 y squared, and the right hand side is negative 1 over 2 x squared, and then plus constant c. And we can move negative 1 over 2 to the right hand side, left hand side. So it will be 1 over 2 x squared, and then plus 1 over 2 y squared equals constant c. And finally, it will be x squared plus y squared equals 2c. Okay, and as we know, x squared is greater than or equal to 0. Y squared is also greater than or equal to 0. So the sum of them equals 2c. It means that 2c is also greater than or equal to 0. Okay, so 2c is a non-negative value. So we can replace 2c by a non-negative value. So square number can be replaced, okay? Square number. So we can let 2c be a square number which is non-negative. Alright, so the equation can be written as x squared plus y squared equals r squared. Alright, so you can see this one represent an equation of circle, okay? An equation of circle. So it means that the differential equation of variables looks like this. Looks like this one, okay? Or maybe the general solution of this exponential equation is x squared plus y squared equals r squared.